All right, guys, so just finishing up the notes that we started yesterday for 8.5, which was about factoring quadratic trinomials that has a lead coefficient of 1, right? They all start out with like 1x squared or 1y squared or whatever. All right, but we didn't get to example 4, example 5 yesterday, so this will be a good lead into our work time. Remember that, big idea is that when we factor, we're just really dividing out an already multiplied expression. We learned how to multiply a binomial times a binomial in the first part of the chapter. Now we're learning how to divide a trinomial into two binomials. Okay, that's what we're doing, big picture wise. The key is that you know how to do it. All right. So our word problem says the area of a rectangle is given by the trinomial x squared minus 2x minus 35. What are the possible dimensions of the rectangle? Okay, there's a clue here in the types of problems we're doing that we're probably going to factor. But this problem also reiterates what I just said. When we factor, we're talking about dividing, right? So what they tell me is that the area of this rectangle is x squared minus 2x minus 35. And what they want to know is what's the length and what's the width. In other words, what times what gives me x squared minus 2x minus 35, right? So in order to be able to do that, we think factor. All right, that's what we want to do. All right, so just to kind of get us going again, what we're really looking for. Well, we know that when we factor, they're going to start out with x plus or minus something times x plus or minus something. We know that because it starts out with 1x squared. Okay, then we start to think about our combinations. So our combination needs to add up to -2, adds to b, and multiply to -35. Multiplies to c. When c is negative, in my opinion, those are the toughest ones. So I like to write out my multiples of 35. Okay. So let me just do that. So ways we can make 35. 1 times 35. 2 doesn't go in, 3 doesn't go in, 4 doesn't go in, 5 does. 5 and 7. So really we don't have too many combinations to choose from. So that makes it a little bit easier. Which combination are we going to be dealing with here? The 1 and the 35 or the 5 and the 7? Luke? 5 and 7 because they're 2 apart. So Luke, do you know which one is, or anybody, do you know which one is positive and which one is negative? Luke, go ahead. -7, yeah, we want our bigger one to be negative. That doesn't really make sense, but you know what I mean, because our sum is negative, right? So that tells me then that the rest of my expression is, one of them is -7, one of them is +5, right? And if we ever want to double check our answer, we can just multiply it back out and see if it really does give me that area, okay? So like if this were a test question and you wrote your answer out like that, I would give you full credit. What they're really wanting you to say, though, is like L equals x minus 7 and W equals x plus 5, right? So just kind of separating them as one is the length and one is the width. Okay, I wouldn't really care. If you wrote it like in normal factored form, that'd be fine with me. Okay, big thing on that one would be, do you recognize A, that you need to factor, and then B, can you execute by factoring correctly? Okay, that's what I would care about. Any questions on that one? All right, so let's look at these weird looking ones at the end that have a second variable on them. And for now, we're just going to kind of cheat them in that they're basically the same as the other examples, but just one extra little thing. But when we learn our next lesson, I think we'll cover 6. I think we'll go all the way to the last section next, cover 6, 8 next. So after that, these will make a little bit more sense. So this is a good preview maybe into that, okay? anyways, let's go ahead and see how we can cheat these. So we almost want to just imagine if it says x squared plus 6xy minus 55y squared, what you want to see kind of in your mind's eye is just x squared plus 6x minus 55. It's going to be the same math, right? And then we'll worry about how to get that y in there at the end. Okay, so let's just factor what I wrote out by hand there. All right. So we know it's gonna be x plus or minus something times x plus or minus something. So now figuring out those somethings is the key, right? So what adds together to make positive 6 and also multiplies together to make negative 55. You might want to write out your 55s. Combinations that multiply to 55 is what I mean. Okay. I'll give you a second to think about it. Let's see if we can come up with it pretty quickly. I'll write up some clues on the board while you're thinking about it. Luke's already got it. All right. What'd you get, Luke? Minus 11 and plus 5. So let's make sure that works on both. So negative 11 plus 5 is going to be equal to negative 6. I think you got the right idea, but that combination doesn't work. Do you know how to fix it? Yeah. Negative 5 and positive 11, right? And we know we want the bigger one to be positive because our sum is positive. But, you know, that's why you need to check, though, because it's easy to mix that up. Okay? So we said let's try negative 5 and positive 11. So that works there. Negative 5 times positive 11 also works there. So that's our winning combination. Okay. So it doesn't matter which one's which. Let's just call the first one x minus 5 and the second one x plus 11. All right. So if I multiplied what I just did, I would get this, right? But remember, we don't really want that. We want this. Does anybody have a guess as to where the y would fit in? If not, that's okay. There's no reason you should know, but does anybody have a guess as to where we would just throw that y in? Would it be attached to like the x, you think, or the minus 5 and the plus 11? Yeah. That's where we put it. Yeah. So it just goes onto those two end terms. Okay. That's the only difference. I think there's only one of these on Math Excel, if I remember correctly. So yeah, you just throw a y there and a y there. Okay. And that's it. That's the only difference. Okay. Just throw on an extra y at the end. All right. So let's do one more together. Actually, let's see what time is it. Yeah, let's work one more together real quick, and then we may just skip that last one. So I think if we do two, that's probably good enough. All right. So we know that at the beginning now, our final answer is gonna be in the form m plus or minus something times n. Okay, so we know to attach that n at the end times m plus or minus n, something times n. All right, so now we just try to figure it out. This one also has a sum of positive 6 and a product of negative 27. Anybody know what the combo is? Luke, man, you're gonna be my superstar. Let me give everybody about 10 seconds to see if they can figure it out. We know one's positive, one's negative. Okay. So you're thinking which pair has a difference of 6, basically, and then you decide on your signs. Okay, couple people got it. I'll give you about 5-6 more seconds, see if you can come up with it. All right, Ms. Coleman, what'd you come up with? -3, +9. Let's make sure they both work. So -3 plus 9 is equal to 6. -3 times 9 is equal to -27. That must be our winner. So our final answer, m minus 3n, m plus 9n. Okay. So those are a little weird. Okay. I probably really should show you this after I teach you how to factor by grouping, but that's all right. This will be a good segue into that. If you want to try that last one, that's fine. I'll leave that up to you. You could check it by multiplying, or you could ask me, or you could look at the filled out notes, okay, because those are posted on Google Classroom. So I'll go ahead and stop the video there, and we got a few minutes to kind of get to the 8-5 assignment. So just kind of maybe take a deep breath and walk around for a minute, and then transition into that.